Okay. So I know you've seen a little bit, okay, but I walked around and kind of looked, and I just want to make sure that we get in the right direction, okay, when we're labeling our variables. So you're actually going to do a project like this. You are going to pick a business and 2 things that your business is going to sell. I don't need you to be realistic. You can actually be as fun as you want. So I've had somebody do tacos y gatos. They sold tacos and robot cats in their restaurant, okay? I've had somebody sell rainbows and sunshine, okay? I'm good with whatever you want to decide because we're not being also super real life in the context in that we're only going to develop 2 constraints besides like the greater than or equal to 0 ones. And really in a business, there'd probably be a lot more than 2 constraints that you'd have to analyze in your little region there. You'd probably have all these different lines going everywhere. But we're limiting it to 2. And we'll give you 1 constraint. We're going to tell you that you cannot spend more than $10,000 on producing your product. And then you are coming up with the second constraint, which is actually an extremely difficult task if you actually want it to matter in the problem. Because with the Legos, if we moved one of those lines in our graph, if we took one and we moved one so that it doesn't intersect the other at all of a sudden that other restraint doesn't even matter because it's this one that's doing all of the deciding. And then we wouldn't produce both products at all. We would end up just producing one of one kind or the other because that would be what's cheapest. So the hardest part for you is going to be able to develop another constraint that actually works with the numbers that we've given you. And you can just adjust your numbers. Again, it doesn't have to be realistic, so you can change them a little bit. And you'll either decide something like time, like I only have 600 hours to produce this, and it takes this long to produce this one and this long to produce this one. Or you can choose space. I only have 1,000 cubic meters of space, and this product takes up this many cubic meters to store, and this one takes up this one, and that's another constraint. So we're giving you the money, kind of the cost constraint, and then you're coming up with some other constraint on your own, okay? And so that's kind of the hardest part of the problem is building it. So here's a problem that we have. They've labeled the variables for you. So X was number of Hershey's chocolate bars ordered and cases, and Y is the number of cases of popcorn ordered. This problem is a little extra complicated by the case factor, right? That they can only order it in cases, but a lot of the information was about units, which are the individual candy bars, not like the entire case of them. So that's why when you guys look at this chart here, you guys had more stuff to fill out than you might when you design your own, because we had to translate like cases and units. If I designed my own where I just told you how much I paid for unit, it would eliminate this whole extra piece right here, right? Okay, so what variable are they using to represent cases of Hershey bars? Elin? X, good. And then our popcorn? Cases of popcorn is Y. So if we want the total of those for anything, if that ends up being something of our constraints, that would be X plus Y. Okay? All right. Now, everything has to be written in terms of X and Y. So remember, with all these problems, we write everything in terms of what we're trying to determine we should order, which in this case is cases of candy bars and cases of popcorn. So next thing is number of units, okay? So how would we calculate how many candy bars and how many popcorn jars, not cases, okay? So how many Hershey's bar come in a case? 30. So that means every time I order a case, I'm getting 30 candy bars. So the number of candy bars is calculated by doing 30 times X. Okay? How would we find the number of popcorn jars? What's that? 10Y. 10 jars come in a case, right? So since Y is our number of cases, we would do 10Y. And if we want to add up the total number of individual units of anything, we would be doing the calculation of 30X plus 10Y. Okay. All right, what about cost? So it's costing us a certain amount, and that's limited here by a constraint. How much does it cost us to order a case of Hershey bars? $10. So the case is 10 times however many cases I order, or the cost is 10 times however many cases I order. What about cases of popcorn? How much do they cost? 20. Okay, so my total cost will be calculated by doing 10 times x plus 20 times y. Right, and then how about profit? How much profit do I make on a case of Hershey bars? So when I sell all the candy bars, I have $30, but I paid for that case ahead of time, right? My profit's only 20 because my profit is what I'm making minus the amount that I spent on that, right? So 20 for my case of candy bars. And then what about for my popcorn jars? 30. Okay, so $30 a case there. So if I want to calculate the total amount of money that I'm earning, it's going to be 20 times x plus 30y. Okay. All right, now if you look right below this, it says to write your constraints, right? So I'm going to use this screen so I don't have to take off the little equations that we wrote, and I'll box the stuff that's in our constraints. First of all, what are the real-life constraints that we should automatically include despite all the information they gave us in the situation? Ariane? Good. So x has to be greater than or equal to 0. Write that down. Okay, so constraints. We're going to have x has to be greater than or equal to 0. And what else? Chris? All right. Also, y has to be greater than or equal to 0. So these are two of our constraints. What else was a constraint in this problem? Something we have to work within. Let's see. Emma. Okay. So is it 400 cases or 400 units? So go read it really carefully. Elin? Units. I know it's super tricky because they only sell them in cases, but they said units when they did the constraint. So number of units is going to be constrained, which means it has to be less than or equal to 400. So this is one of your constraints or restrictions as well. Okay. What else was a constraint or a restriction on us, right? So the amount we're spending has to stay at or below $500. So right here was our cost. I have to keep that less than or equal to $500. So that's also a constraint or a restriction. So we have 4 constraints or restrictions. 2 are these greater than or equal to 0 ones, which are just like the context of the problem. We can't make negatives. And 2 are dependent on the information they gave us in the problem. Is that okay with everybody? That those are our constraints or restrictions is what they would call them. All right, so the next thing on your paper says, write the objective function. So what is your objective in this problem? Our objective is to make as much money as possible, right? Okay. And so we want to look at how we calculate that. That is our objective function. So your objective function is your profit equation, okay? This is profit right here. So this equation is our profit equation, okay? And remember we had some kind of funny notation about how we named it. But we used P for profit. We used an X and a Y because we're plugging in 2 things. But it's 20X plus 30Y is how we would calculate our profit. Any questions about constraints, restrictions, okay, or objective function or our profit equation? Yeah. So in the problem, it said that we could only order 400 candy bars or popcorn jars in total. So we are just constraining the number of things that we can have, okay? Any other questions about our constraints or restrictions or profit equation or objective function? Same things, okay? All right, so now what are we going to do with this if we want to figure out how to maximize this profit equation? First, we're going to graph it, okay? The graphing part you might not think is very important. However, it is important because if you were running a business and you wanted to present something to people, you need to be able to visually show them what all the possibilities are that they could do and then what those possible maximums and minimums are. But there could be other things that come into play that then limit people. So though we're looking at this very simplistic situation, the graph really gives us all the possibilities and we can choose within that if we were ever in a situation where we couldn't reach the maximum or minimum or something like that. So I'm going to give you guys a few minutes. I want you to go ahead and try to create a graph of all of your constraints. you would have that shading, and it should be confined in a quadrilateral, right? The reason I would think quadrilateral is because we have 1, 2, 3, 4 constraints. So if they all contribute to trapping in this region of possibilities, it should be a 4-sided figure, right? Weird sides, not like a perfect rectangle or square, but just a quadrilateral, okay? So we should have a feasible region that's a quadrilateral with the shading in there. And then if you're feeling comfortable, you can go ahead and look for like those vertex points and which one might maximize our function, okay? So go ahead and create yourself a graph. See if you can graph it. Every time that you do it, it does. So I'll just do it again. Okay, so constraints that you guys should have. The x is greater than or equal to 0 and the y is greater than or equal to 0 automatically limit you to this first quadrant, okay? And then you guys had one equation that said for your restrictions besides the ones where it's greater than or equal to 0, you had the restriction of number of units that you could house that you had to keep below 400. This should give you guys an x-intercept of 40 over 3, which is like 13 1/3, and a y-intercept of 40, okay? And then I didn't graph mine yet when I figured that out because I wanted to see the other x and y intercepts so I could scale appropriately to kind of know which region I really wanted to look at. And so your other equation, which was cost, said it was $10 per case of the candy bars and $20 per case of the popcorn jars, and we had to keep that below 500. Okay. So that linear equations would give us an x-intercept of 50 and a y-intercept of 25. So with that information, I decided that I would want to label by 5s. Seems good enough because it would give me like the 25s and stuff in between. I know the 13 1/3 will be a little bit weird, but we are talented enough to figure that out. Okay, so I went ahead and labeled by 5s. And then I went ahead and thought about our constraints. So your greater than or equal to 0 constraints, we already know confined us to this first quadrant, that they've kind of encaptured this area up here. And then this constraint about how many units we could order, if I plot those intercepts, so again, 13 1/3 I know is a little bit whatever, but it's between 10 and 15 and a little bit closer to 15. And then 40 as my y, 25, 30, 35, 40. Okay, gives us something that looks something like this. And this second constraint on cost gave us that x-intercept of 50 and the y-intercept of 25. So that line looks something like this. So our feasible region, the choices we have are covered by that quadrilateral that we've graphed right there. Okay? So we can order any amount of cases of candy bars and cases of popcorn that falls as a point inside of this region. However, the points that will maximize or minimize our profit are the extreme vertex points of the quadrilateral. So this point, this point, this point, and this point. Okay? I know 3 of those 4 points right now because I graphed by finding intercepts, which is extremely useful in this context because of the way the equations are given and because we need them for the graph. So I know this point at the origin is 0, 0, so that's one of my vertex points. This x-intercept right here was that 40 over 3 or 13 1/3. Okay. This y-intercept up here, okay, was from that red line, so that was 25 that it was crossing through. And how am I going to find this point of intersection out here? The system of equations, okay? So comparing the 30x, well, let's just look at them first. if I want to compare this to this, but I'll have equal signs in here, I'm thinking maybe I'll multiply the top equation by -2. Because that will make a -20y, and then I can just cancel it out with the y's that are there. And 2 is not a very large number, so I don't mind multiplying by that value. Okay? So I'm going to go ahead and do that. If I multiply that first equation by 2, I would have -60x minus 20y equals -800. So I multiplied by -2. And then I'm combining that with the second equation. And again, I know I'm doing this part first. You guys are fully supposed to know how to solve systems of linear equations. And if it's a struggle for you, you should come in and get help. So I get -50x equals -300, which tells me x is equal to 6. Okay. So this point here is 6, comma. And then how am I going to find the y value of that point? Elin? Good. I'll plug in x to one of my equations that I used right here and solve for y. And we do that, we should get 22. Okay, so the other vertex point that we're checking, and I know I'm skipping some steps here, so just as you guys are getting used to this class in our first month here, we don't have a lot of time, as you have seen, with the amount of material that we have to cover. So we won't go through every Algebra 1 process when we have to figure something out. If you don't know how to do it, you need to come in individually and get help, okay? Because we're making a huge assumption that your foundational skills are solid and you know where we're getting those numbers from, okay? So this is our last and final vertex, 622. Now we need to evaluate P at each vertex to see which one actually maximizes profit, okay? So I'll tell you guys right now the P of 0, 0. I know that one. Okay, I'm so talented. When we plug in the point 0, 0 to our profit equation, we're going to get 0, okay? If we don't order any cases of candy bars or popcorn jars, we're not going to make any money. So let's do this. This side of the room, can you guys find P of 13 1/3, comma 0. Now you guys have a tricky situation. Is 13 1/3 something you can actually order in the context of this problem? And you call someone and be like, I'll take 13 1/3 of your cases. Not if they sell them by cases. So how are you going to actually go ahead and calculate the profit? You're going to have to round this to 13 and plug it in, because 13 1/3 is not actually something that's feasible in this situation. So that side of the room, can you guys find the profit for 13 cases of candy bars with no popcorn jars? Center of the room, okay? Can you guys please find the profit for no cases of Hershey bars and 25 cases of popcorn jars? And this side of the room, far side of the room, can you guys find the profit if you order 6 cases of chocolate bars and 22 cases of popcorn jars? Anybody have answers for us? Yes, Emma. For yours. This one? 260? Yeah. 50? And this side of the room? 780? Okay, so each of the numbers you just found is the number of dollars you would make if you ordered this many cases and sold them all, okay, of each product. So you can see that selling just Hershey bars is kind of like not even close to the maximum profit that we could make with what we could afford to do there. However, selling just popcorn jars came pretty close, okay? But this combination of 6 cases of Hershey bars and 22 cases of popcorn jars would give us the maximum profit of $780, okay? Is this okay with everybody, the process? So constraints and restrictions, profit equation, you graph all of your constraints to understand what all the possibilities are in this little shaded region that you could do. And then you use the extreme points of that feasible region to plug in and find what things could minimize or maximize your profit, okay? So you guys are going to be doing this